rise.
Okay, so these were the basic concepts with height, that is rise, the crown, 3 hinge, 2 hinge, and the
Fixed type of arches.
then we saw another category under the hinged arch, 3 hinge arch was when both of them are at same level. So this is your same level at same level, arches at same level, or you can have arches which are at different level, right? So this remains the crown. So from a crown, when I draw a drop of perpendicular, so something like this becomes the L2, this becomes your L1, this is the crown, and rise for the first level, this becomes H1, and for the second one, this becomes H2, that is the rise. So this is a case wherein it is at different levels. Supports are at different level. This is supports are at same level. This is same level. This is different levels. Okay. Apart from this, I think we also have seen simple derivation when it is a circular arch. So as you first, a circular means it will have a radius, right? So R will be there. So this is your, I'll show the R in this direction for the radius. This is the rise. Here you have points A and B, and then this becomes your L by 2, L by 2, because length, total length divided by 2, L by 2, L by 2. And somewhere at this point, we consider a point D with coordinates X and Y. So this was X, this is Y. And for this, some parabolic equation and all, we saw some derivation kind of stuff. So before continuing with that, yesterday when the derivation that we saw, or the formula that we are going to make use of from yesterday's session, I will make a note of that so that you will get used to that particular formula when we are making when we are solving the numericals. So we got a formula for rise or rise equation of parabolic arch. Okay, rise equation of parabolic arch we have derived yesterday. It is y equal to 4hx divided by L square into L minus x. Okay, so this is the equation for rise when we are calculating an arch or a parabolic arch. So if I give you a numerical wherein you have a arch diagram like this, and this is your total mid rise h, and in between if I want to find somewhere, so say a point y, that time I will make use of this equation where this would be my x distance, at what distance I want this rise. So this would be the x distance which I have to input, total the length, that is the span L, and h is your total rise, whatever rise you have, and then L minus x. So this y would be able to, we would be able to find this height at any other point, section point in a parabola using this equation. And today you will see we will make use of this equation while solving the numericals. Okay, so that is one of the important equations that you have to keep in mind. Then coming next to, we had just started. So I'll just draw the figure once again. That is analysis of static loads. Analysis of
Mhm.
that. Yes.
Yes. Somebody said, ma'am. Any doubts? You can put it on the chat box.
I'm not audible.
Hello?
Yes, ma'am.
I'm audible?
Yes, ma'am.
Clarity is there?
Yeah, ma'am.
Somebody said ma'am, no, in between?
Or they were talking probably somewhere else. Unmute kar diya, huh?
Put your phones on mute if you are busy with something else also.
Okay. So coming next to analysis of static loads. So now when we have a arch like this,
When you solve numericals, they will be giving you the type of
loading that is coming. So say this is a 3 hinge arch, okay, given to you, and he'll give you the rise h, and he'll give you the overall span L
of the
arch, and then this also would be a hinge. He'll mention whether it is a hinge or not. If it is a 3 hinged, meaning this is also going to be a hinge, and then he will give you the loadings like this. On top of this, he will draw a beam like a structure, and then he will give you loadings. Either it could be a UDL, it could be a point load like this, okay, with W1, W2, and W per meter. So they would have given you loads like this. Using this loading system for the hinges support, I have to first find the reactions. Okay, methodologies, I'll be finding the reactions, and then if they ask me to find the particular depth using that parabolic equation, we will be going ahead for finding the bending moments also. We have to find their bending moment and draw the bending moment diagram. For an arch, we will be drawing the bending moment diagram. I'll tell you how and all. So to do all this also, our basic, we are going to use equations of equilibrium, that is summation f of x equal to 0, summation f of y equal to 0, and summation m. When I'm saying summation m, it could be ma, that is this point, or it could be summation mb, that is this point. Okay, ma, mb, or it also could be summation mc, that is because this is also a hinge, three hinged arch, so this is also hinge, so it could be summation mc equal to 0, any of these three cases. Right. Now say we know that these two are hinges. So when it is a hinge, I'll have a horizontal and a vertical, horizontal and a vertical. I know the number of reactions that are going to be here. Right. Now horizontal loading, if it is not present, so your h is basically becoming 0. So that time I can exclude the summation f of x or summation fh. That time you will have a reduced, because I know that ha is going to be equal to HB, which is equal to some H and or 0 depending, and I can totally exclude this reaction. Instead of that, what we will be making use of, that time I will go ahead with only summation f of y equal to 0, summation MA or summation MB equal to 0, and summation MC equal to 0. So these are the equations of equilibrium that we will be using. Same what you have done in beams only. Nothing different. Only the way of telling would be different in this case. Okay. Then apart from this, we find some reactions. Yesterday while closing, I told no, like how I have, when I analyze a beam, I'll have bending moment and shear force as my output, and because bending moment and shear force is important for us in the designs. Similarly, in case of your arches, the three main parameters that we find are, it's going to be radial shear. They'll ask you to find radial shear. They'll ask you to find the normal thrust. Okay, and they will ask you, third one is to find the vertical shear. So these three are important. So for this, there is one equation, and apart from that, we will be using the regular some equations of equilibrium and drawing the bending moment diagram also, and finding the reactions also. The rest procedure is going to be same. Now coming to what is this radial shear or normal shear, how to find that, we will be requiring some part of your, where did I keep the duster? Okay. We will be requiring some part of your engineering mechanics here. When yesterday I told you, resolution of a force. So this is how the arch section is going to be. I'll not draw a double figure, only a single figure. So it is going to be a curve in the nature. So what happens is, normal thrust is always going to act like this, N. Okay, where I write somewhere, N stands for your normal. Usually you are aware of that. N is perpendicular, no, N is normal. Then you have something called as Q. Okay, you'll have a Q, and you will have a, I'll use a different pen or else, horizontal force H acting, because whenever there is a curve coming, you will come across horizontal, that we have seen yesterday. Yesterday when we were discussing. So apart from this, if this is a hinge, you will have HAVA here also. And the other way also, you will have other junction also. When I complete this arch, I will have a HAVA. And if there is a hinge over here, if this is a crown and a hinge over here, there's no HAVA. Moment at that point is going to be 0. So what is our next job is, I'll have to find the normal equation for normal thrust and equation for radial shear. So normal thrust and equation for radial shear. radial shear. Okay, I call it Q. So these are the two main things that we have to find based on this. How we find is, this is your arch section. People keep joining like this, no, then it will be a disturbance to me. This is your arch section. Along that arch, you will have a normal force acting, and this is your horizontal. He will give you this is as theta. Okay, and then if I assume this to be your horizontal axis, and I'll have a vertical axis like this, okay, that would be your vertical shear V value. Now, our job is I have to uh, have or resolve H components and I have to resolve V components. Take both horizontal components in one place, take both vertical components in one place, and that gives me the normal, that is the normal thrust and the radial shear. So if I want to draw it one by one, at once if I draw, it would be confusing. So one by one, if I draw, so this is your curve, okay, and here this is your normal n acting like this, and then you will have in this direction your radial shear Q, because this is how your circle goes, no, right? So radial shear is always along the radial. So this is your Q, and then you have this H coming into picture like this, and it is acting at an angle theta. He will give you. So if I assume this n, because it is normal extended line, this is horizontal, so I can have a perpendicular to this also, no, vertical like this. So this is going to be your vertical axis. So if h I extend, it goes in this quadrant because of the sign convention. This is theta, this becomes theta, and when I resolve this force, this is going to be h sine theta, and this is going to become h cos of theta. Believe me, you will not require this. I'm just telling you how this is coming into picture. So H force, that is the horizontal force that is coming in the curved beam, that is the your arches, is going to be resolved in this manner. Okay. Then I have one more figure or same arch, and you will have a normal here now. I'm drawing it separately two times because two different forces. So your Q is like this only, same, no change in the Q. And if this is your horizontal axis, you will have another perpendicular axis acting like this, right? And here is your V force, that is the vertical shear, V that is acting. So if I know that this is H and this is theta, this is 90 minus theta, and this I will have a theta force coming over here. So this is acting in the third quadrant. On resolving this force, I will have the components here in the third quadrant. So it looks like this. I'm just telling you how the equation has come. You need not practice this. So this is going to be your V, and this is your theta. So you will have two components in this direction. So theta is with your y-axis now. So this becomes v cos theta, and this becomes v sine theta. So these are your horizontals, these are your verticals. So if I take horizontals in one place and verticals in one place, for horizontals I will name it as Q, radial shear. For verticals I will name it as N, normal thrust. Okay. So now in your horizontals, where is your horizontal? This is your horizontal. You have h cos theta, and in the same direction you have v sine theta. So that is minus h cos theta and minus v sine theta. In the normals, what you have? H sine theta upward, so plus h sine theta, and you have downward minus v cos theta. Okay, so these are your equations. To remove the negative sign, what I can write? Same thing. Q will be equal to, is it, no, Q is equal to, I'll make this as plus h cos theta plus v sine theta, and N is equal to v cos theta minus h sine theta. Okay, so these are your two equations that you will be making use when you are solving the equation. How this equation came is from this derivation. Okay, they will not ask you for this, but you should know, if I have a horizontal force and a vertical force, the components of the horizontal force, h sin theta, h cos theta, the components of the vertical force, that is v cos theta, v sin theta, based on the sign conventions, we are getting the equation for Q, that is the radial shear, and N is the normal thrust. So in the numerical, they will ask you this. So you need to by heart these two equations along with that equation of parabola. Clear? So these three are going to be there to solve the example. So now, without wasting much time, I will take up the example wherein you will understand these things. This explanation, what I gave you for the derivation or this from where the equation came, directly it is written in the textbook. It will not be asked. Just for your knowledge, I have told. If you know the things from the basics, it's always better. Okay, so we'll take up a first example. I am also sitting with a calculator if by chance required. Karke. So first numerical, there is a three-hinged parabolic arch. I will write only the given contents. I will not write the entire numerical. Okay, so there is a three-hinged parabolic arch. So this is the data I'm writing of span equal to 40 meters. So span equal to 40 means L is 40 meters. Span is L, okay? And the central rise of 6 meters. So central rise means crown, that is 6 meters. H is 6 meter. Carries a point load of 100 kilonewton at a distance of 12 meters from right hinge. So if I want to draw the diagram of the arch, something like this. Okay, so this is also hinged, three hinged. So this is also going to be hinged. Okay, and this is also hinged, three hinged. I call this A, we'll call this B, we'll call this C. Then the span is given to us. How much is the span? L equal to 40, and then 40 meters. And then we have the central rise, that is H equal to 6 meters. Correct? Now the loading system I will be drawing above this. From here to here is my B. So above this we will be drawing the loading. For the loading, he says it carries a point load of 100 kilonewton at a distance of 12 meter from right hinge. So this is your right hinge. From here at a distance of 12 meter, it is carrying a point load of 100 kilonewtons. Okay. Okay. So this is how it is. Either diagram is usually not given, they give you in the question, you have to draw the diagram. So now if this is 12 meters, the total is going to be 40, and in central rise is 6, matlab this is going to be 20, this is 20. So this up to here is 20, and in this half is 20. So in that, if 12 is gone, 20 minus 12, 8 is remaining. So this is 8 and the other part is 12. Okay, distances. There is no other load, only these many loads are there. They've asked us to find what is first one, A, calculate the reactions. So what are your reactions? Both are hinged, no? So you will have HAHB and DABB. Okay. Then second one, draw the bending moment diagram. To draw the bending moment diagram, I have to first calculate the bending moment at various points. Then third one, normal thrust and radial shear. Normal thrust and radial shear, but where? This has to be carried out, or this has to be found at 10 meters from left, meaning from left side at 10 meters, matlab somewhere over here at this junction. Okay, I call section XX. At this section XX of 10 meters distance, we have to find the normal thrust and radial shear. This is the equation. So you will get this for more than 10 marks. Numerical, it is quite a lengthy numerical. Okay, so we'll first finish up one and then we will see the other one. So now with these basics, all of you, the diagram is clear, the question is clear. Any doubt with the question and the diagram?
No, ma'am.
Please respond. No, no. Okay. Is this fine? The way of
Ma'am.
teaching is fine?
Ma'am, see, normal
Yes.
thrust.
Normal thrust, what happened?
That question is not understood.
Not understood. They have told find the normal thrust and radial shear at a distance of 10 meters from left. So see, this is your arch, no, overall. Where to find, at what section to find the normal thrust and radial shear is at 10 meters. So from left support is this. From here at 10 meters, I will draw a section XX at this point. So this is your radial. At this point, I will be finding the normal N and the radial shear Q. So that at what distance it has to be found is given. So I have just shown that point. Okay, so you can call this A, B, C, and this what we are going to find is D. Yeah. So normal thrust and radial shear at one point we have to find. He will tell us in the question which point. 10 meters from left, 10 meters from right, or 5 meters from left and right, like that. So this is the question. Your doubt is clear?
Yes, ma'am.
Okay, done. So now to find or to go ahead first, what we have to do is I have to find, we'll go one by one. First, we'll find the reactions. Now, when we talk of reactions, let us draw the free body diagram. Both sides it is hinge. So hinge means you will have horizontal, vertical. You will have horizontal and vertical. Correct? Generally, sign convention, how you do? This is the hinge. So you show horizontal and vertical in this manner when you have a single hinge given. If they give you a beam and they draw both the sides are hinged in a beam. So this side you are showing towards the right edge. So other side they show it towards the left because this is just an assumption. You can always show edge like this also, both positive edges. But usually towards the right side, they show it like this. It is just an assumption, no hard and fast. Okay, so we will be going ahead with this only. So that is why what I've drawn, one HA is here, one HB is this side. One is going in this direction, one is going in this direction. And then you have your VA and you have your VB. So these are the four reactions that I have to find now. So to find the reactions, what we will do, we will apply the equations of equilibrium. What are the equations of equilibrium? We will start with summation f of x equal to 0. Some textbook will write it as summation h equal to 0. Horizontal. Anyone you can mention. Your choice. So what all are the horizontal forces over here? One is this, one is this. So it is HA minus HB equal to 0. Only these two are there. No, is there any other horizontal force? Is there any other horizontal force?
No, ma'am.
No. H is equal to 0. So HA is equal to HB then. I can call it as simply H because when both are equal, I'll simply call it as H. So we will find this and we will keep. Then we will go for next equation of equilibrium, that is summation f of y equal to 0. Also in textbooks will write summation v equal to 0, vertical forces. Okay. So what are the vertical forces? VA, VB, and
Ma'am,
yes,
how HA is equals to HB?
what I wrote here. Shabazz, no, that was
Yes, ma'am.
HA. This is positive HA. Is going towards the right.
Yes, ma'am.
This HB is going towards the left.
Yes, ma'am.
So this becomes plus HA, this becomes minus HB,
Yes, yes, ma'am.
right? Equal to 0
Yes,
because only two horizontal forces. So when this and this HA minus HB equal to 0, I'll send HB towards the right hand side. तब क्या होगा वो HA equal to HB होगा.
yes, ma'am.
So when HA and HB are same, I will give it a common name as H.
Yes, ma'am.
Okay. Next, when I'm writing summation V equal to 0, what all are the forces, vertical forces? VA, VB, and
100 kilonewton.
yes, 100 kilonewton. We are finding the reaction with respect to the loading. Okay, so I'll write VA plus VB. VA is upward, so positive. VB is upward, so positive. 100 is downward. Minus 100 equal to 0. What you do in beams, we are doing same. No change. Okay. This is one my important point. So bracket mein dalo. So this can reduce to what now? VA plus VB is equal to 100 kilonewton. Am I correct?
Yes, ma'am.
Next, summation M. I can take summation MA equal to 0. We can take summation MB equal to 0. Or we can take summation MC equal to 0 because all the three are hinges. So we will go ahead with summation MA equal to 0. Okay. So when I write summation MA equal to 0, what all are the things moment at A? So HA and VA are passing through A. They will not give me any moment. VB will give me a moment. Right now? VB into total span? कितना है? 40. Yes, 40. And it is clockwise or anti-clockwise?
Anti-clockwise.
Anti-clockwise. So minus VB into 40, correct? It goes, VB goes like this. I'm taking moment here, HA, HB also are going through that only. Then 100 into this distance. What is this distance? This is 20, this is 8. So 28. 100 into 28 goes to A in a clockwise direction. So it is plus 100 into 28 equal to 0. Are there any other forces? No. So minus VB into 40 plus 100 into 28 equal to 0. From here, I will get the value of VB, that is 100 into 28 is equal to 40 into VB. So VB would be what? 100 into 28 divided by 40. How much?
70.
70 kilonewtons. Correct. Okay. So I will write it on the top somewhere. So VB is 70 kilonewtons. We found H9. Vp equal to 70 kilonewtons. I will write it on top. Now, we had an equation Va plus Vb was equal to 100 kilonewtons, right? Therefore, Va would be 100 minus Vb. So, what is the value of Va now? 30 kilonewtons, correct. So, Va we found as 30 kilonewtons. Okay. Is there any doubt here? This is like your beam, no? No, nothing changed. यहाँ तक समझ में आया सबको?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Next. In the beam, I used to, when I say HA, we got a condition wherein HA was equal to HB equal to H I wrote, correct? When we were doing regular beams, this was equal to 0 because there was no horizontal and we kept it as it is. But when we are doing it for cables, there will be a value of H because it is curved beam. There will be existence of horizontal force. Now I have to find that horizontal force. That's why I didn't write here equal to 0. I wrote equal to H. Now, how to find that horizontal force is, to find the horizontal force, we have to take the moment at such a place where my H will be giving a rotation. So to find H, I will take moment at C equal to 0. This point we will take as 0. Moment. Okay. So we have to take the moment of all the forces about this point on any one side of the section. That is either this side or either this side. Any one side. Don't take both the sides. Clear? Now when I'm taking moment at C at say from left side, so I will have HA going like this into perpendicular distances 6 and HA will go to C in anti-clockwise direction. So when I say moment at C equal to 0, I'll write minus HA into 6. HA goes like this, perpendicular distance is the rise. So HA into 6 anti-clockwise. So minus HA into 6. And what all comes? VA comes only one side of the section. So what is the VA? VA will go like this to C. What is this distance? 20. So plus VA into 20 is equal to 0. The equation is clear. I'm taking moment at C. I'm taking from this side. Either you will take this half or this half. I'm taking from this half. Okay. So VA into this distance, VA force line of action is like this. C point is here. So VA goes to C in clockwise direction with a perpendicular distance of 20 meters. So VA into 20. Then HA goes in anti-clockwise direction. So minus HA into 6. Okay. So now substitute HA can be written as H only, right? Or, okay. Plus VA was how much? 30 into 20 is equal to 0, or 30 into 20 will be equal to 6 times of H, or H is going to be 30 into 20 divided by 6. How much is this value?
100.
100 kilonewton. You get a H value of 100 kilonewton. So H is nothing but H is equal to HA also and H equal to HB also, right? So they all are equal to 100 kilonewton. Is this step clear? Every numerical you have to do this to find H. Because it is hinged, there will be H. And because it is cable, not cable, arches, So H value will be there. H is not going to be 0. Okay. That time to find H, always I will take moment at the crown. C. C is nothing but the crown, right? So always take moment at C. You will get one horizontal ka moment, negative always it will be, and one because of this reaction. Agar yahan pe there is some loading, then you will take the moment of that load also. Actually, there is no point load or any UDL at this junction. Clear? Any doubt with this? You will get used to this as in when we do more number types of numericals. Okay. So this was your first step wherein you found all the reactions, unknown reactions, that is VA, VB, HA and HB. Any doubts still here? Shall we go to the next point? Second, I have to calculate the bending moments. Let us calculate the bending moments and draw the bending moment. Always, I have to make use of this. That means you have to practice this equation. Now, what we will do, this first I will write generalized. So, y equal to 4 times, what is the value of h? It is 6. X we do not know. We will keep x as it is. L is 40. 40 square, L square, into 40 minus x. Open the brackets and solve for this. So, when we solve for this, 4 into 6 divided by 40 square. Okay. 4 into 6 divided by 40 square will give me
6.25.
0.015.
Yes,
Check
ma'am.
karo. Shabas.
Yes, ma'am.
0. Correct, no? 0.015 into 40 minus x I am getting. Y equal to. Okay. Now again I will open this bracket. So this into 40. So it is going to be how much? 0.6. Okay. Minus 0.015 times of x. This is our generalized equation for, or parabolic equation, rise and slope equation for a general case with some distance x. Now when I want at x equal to 10, I will put x equal to 10 over here. If I want x equal to 5, I'll substitute x as 5. So this is a generalized equation. कुछ गलती हुआ क्या? This is x.
Ma'am, x.
Yes, yes. This is x. So this becomes x and this becomes x square. Correct. So 0.6 x and this is x square. So this is your generalized equation. Now, when I'm drawing the bending moment diagram, I will need to locate its distance and I will need to locate the maximum bending moment also. So this is equation for y. So I want dy by dx, that is first derivative of this equation. So it is dy by dx, that is nothing but slope, which is equal to tan of theta. You have to write it as tan of theta. By tan of theta, you will understand when you are studying slope deflection. I'll get back to this again over there. For now, you just remember that dy by dx is equal to tan theta. What is dy by dx? Y equation रहता है ना, उसका first derivative. Okay, so dy by dx equal to tan of theta equal to, if general, if I want to take, then you will have to differentiate your this equation, y equation. So what is your equation? D by dx of y is 4hx by L square into L minus x. I have to differentiate this. So when I want to differentiate this, I will open the brackets. It is d by dx of 4h, L cancels, right? 4hx divided by L minus 4h x square by L square. Okay, we have to differentiate this. So instead of going like this, what we can do is, where is my eraser? So instead of doing this, what best way to find the derivative is to directly substitute the values. Like for example, you know the values of L and all, no, for your given problem. So you directly substitute that value. That is 4h. Okay. Differentiation would be 4h divided by L square into L minus 2x. if I open the brackets and I differentiate. So now in this I will substitute 4 into h is 6 divided by 40 square into 40 minus 2 times of x. When I open this bracket, this is going to be 4 into 6 divided by 40 square. This is 0.015 only into 40 minus 2x. So this into 40 gives me 0.6 and 0.015 into 2 gives me minus 0.03 times of x. So this is your dy by dx equation. Okay, so dy by dx equation is 0.6, or if I skip this step also, I mean, I was just following mathematical steps. I got a y equation. I can directly take dy by dx from here. I will differentiate this. So dy by dx of this equation is what? 0.6 minus 0.2 into 0.015, that is 0.3 x. Directly also I can take. No fast. But one step you have to show why you're taking dy by dx. You write this step and directly you differentiate this also is okay. No need to show the entire thing. Right? So I will write both the equations now. Whatever two equations we have got, those both are important. So coming to, you got y as 0.6 times x minus 0.015 x square. This was your y equation. And dy by dx equation you got as 0.6 minus 0.03 times of x. So you landed up to these two equations. This is what we have to do always. Clear? Next. Now to calculate with this, I have to calculate, to draw the bending moment diagram, I need the value of moment at A, which is 0. Moment at A is going to be 0 no, because it is a hinge. Moment at B also is going to be 0 because it is hinge. And moment at C also is going to be 0. So first write moment at A is 0, moment at B is 0, and moment at C is 0. Why? Because they are hinged at those junctions. Then which ones we have to find? Apart from this, I can find two more places moments, that is moment at point at D and moment where there is point load. Okay, he has asked you in question, no, the normal thrust and radial shear at 10 meters. So from here at 10 meters, we can find the bending moment at this junction and a junction where there is a point load. So what we will do apart from this, we will find the moment at, if I call this as D, moment at D and this moment at point load. So moment at point load MP I will call it. So now our job is to find moments at these two places. How to find the moment at these two places is, you have your y equation. So I need to find this y. This is nothing but your y. Okay. So in this equation, I know at x equal to 10 meters, if I want, I will substitute x as 10, I will get the distance y, this y. So how it is this is your arch and this is your equation for the arch, correct? So say you will have some x over here, with respect to that x is going to be this y. So when I put x equal to 2 meters in this equation, so whatever value of y I get is going to be the height. Okay, say I'll put x equal to 7 meters, like this. X is 7 meters. So with respect to 7 meters, whatever is this would be your y value. You will be getting the y value. So similarly now, in our case, what we have to do is, we know that in our problem, we need to, this is your central edge, which is 6, at from this junction 12 meters and at 10 meters. Right? I need to find these two y's at x equal to 10 and at x equal to, from here if you take, this distance becomes 28. So at x equal to 10 and at x equal to 28, you have to substitute in this y equation and get the values of y, that is the height of the parabola, correct? So let us do that now next. So to calculate that, what I do, the same figure, I will draw a different figure probably because too much of writing has been taken place. So this is your parabola. Okay. And this is your central. You have a point load over here, that is 100. I'll call this as y. Okay, and at 10 meters. This is y, or call this as yd and ye. Okay, yd and ye. I'll call this point as d and I'll call this point as e. This is our c, a, b, c. Nomenclatures, whatever you want, you can put. So total was 40 meters. So half of that is going to be 20. They have asked this point E that is thrust at 10 meters, meaning your x is here 10. Yes?
Ma'am, it's half visible.
Half visible. Now,
No, ma'am.
not
Ma'am,
visible.
half portion is visible.
This small diagram is visible.
Yes, ma'am.
This only you focus. That's why let that go on top. This diagram you focus. Okay.
Ma'am,
Your
that
regular.
diagram is just half visible.
Left side में left side
Still
में
is not visible.
Ma'am.
ಇವಾಗ ನೋಡ್ರಿ.
No, ma'am.
Not visible.
Left side corner, ma'am.
Huh?
Left side corner.
Bending moment is visible. This I've put my finger.
No, ma'am.
No, ma'am.
What is?
No, ma'am.
Okay.
No, ma'am.
I'll just restart that cam option. Wait. Give me 2 minutes. Doesn't happen. You all can also no. Don't refresh. Don't leave the meeting.
Ma'am, if phone is rotated, it is visible.
Phone is rotated, it is going to, it is connected through an app, phone and laptop, both are connected. I will just restart. Okay, I'll just restart. Give me 1 minute time. I'll close the application and start the application. It was not visible from long time or what?
Yes, ma'am.
But ಹೇಳ್ಬಾರ್ದು.
Ma'am, if we rotate the phone, it is visible. It is visible for me.
If you rotate the phone, okay, right.
Yes, ma'am.
I get that. Yeah, I get that. Must be that is the issue, because for me, I've pinned a video on the screen. For me, entire screen is visible, but I am not observing it. Ashte. Where it went now? Check.
Yes, ma'am.
It is visible.
It is visible. You all can rotate your phones. I think that is landscape. Rotate option is locked. Unlock that. When we watch videos, we rotate, no? Like that, you rotate your phones horizontal landscape. So that time the entire video will be visible. Now it is visible?
Yes, ma'am.
Yes, ma'am.
Okay. So now where was I? Okay. So this is, we will just find the bending moments for today and we will stop, or else you will get confused. So total span is 40, half span is going to be 20. Normal thrust and all I have to find at a point 10 meters from left side. So 10 meters, I need this Y. So I call it YE. I've named this point as E. And our point load, no, 100 kilonewton. It is at 12 meters from this junction. Right? So what is this side now? 40 minus 12 is going to be 28 meters. So this distance is 28. This is 20, makes it 40 into 10. So UL2, that is YE and YD. हमको ये दोनों अभी ढूंढना है. To find that, what we will be doing now, I have to directly substitute in this equation. So first, let us say you want to find for bending moment calculation. Okay, I require the value of YE and YD. So to get YD, okay, I will use 0.6 times x minus 0.015 times of x square. Put x equal to, what value should I put for x? Tell me.
28.
You can put 28, you can put 12 also. Both values will be same. Okay. One can check it with 28, one can check it with 12. Both values will be same. Okay. Or I will put an or over here. Put x. So YD now equal to 0.6 times of 12 minus 0.015 times of 12 square. Let's see what is the value. 0.6 into 12 minus 0.015 into 12 square. YD is showing how much? 5.04
5.04.
meters. Say if I put 28, what is going to happen? 0.6 into 28 minus 0.015 into 28 square. Again 5.04 only you get. Okay. So whether you put this or that, because equation is same, no, parabolic equation. So this or this value is going to remain same. So YD is 5.04. Similarly, I want YE. So for YE, put x equal to 10. I will put x equal to
4.5.
10. You get 4.5. Okay. 0.6 into x minus 0.015 into x square. That is 0.6 into 10 minus 0.015 into 10 square. 4.5, huh? 0.6 into 10
Yes,
minus
ma'am.
0.015 into 10 square. Yeah.
4.5 ma'am.
4.5. You got the values of y now. So I'll just write down the values. YE I'm getting 4.5 and YD I'm getting how much? 5.04. Correct. So using this equation, we found the two values of y. So that is why your that parabolic equation is important. Once we find the distances, now I will write moment at d and moment at e. So when I'm writing moment at d, okay, I will write here only directly. Look into the figure. First, I write moment at d. There is a sketch pen. Then I'm taking moment at this point. What all should I consider? This 100 is passing through it, so that 100 will not come. Only one side of the section. So VA is there, HA is there, VA, HA, anything else? BB will not come. One side of the section. Now, when you are doing beams also, bending moment at in midpoint, any one side say you come, not on both the sides. So when I want moment at this point now, moment at D, it will be VA into this total distance. That is VA into 28 and HA into 5.04 minus H into 5.04. Clear? So VA value I know. VA is 30 into 28 minus H is 100 into 5.04. What is this value? 30 into 28,
336.
100 into 5.04. Yes. It is 336 kilonewton meter moment at D. This is. What I did, I wanted moment here. Any one side of the section we take always moment. VA into this distance is 28 and HA into this distance. That is 5.04. We got the moment at D. Similarly, write moment at E. If I'm writing moment at E, now it is VA into 10, HA into 4.5. Correct, no? Only that will change. So when I'm writing moment at E, it is going to be VA into 10 because this E point is at 10 meters from here. So VA into 10 minus H into 4.5. This height is 4.5. So 4.5. So 30 into 10 minus 100 into 4.5. How much?
Minus 150.
Minus
Minus
150.
150.
150 kilonewton meter. Right? Apart from this, rest all moments are zero only, no? The other values we have? No. Moment at A and B are zero. A, B, C are zero, and these are E and D points. So these are our moment points. Okay. So now we will plot the bending moment diagram. So just observe how we plot the bending moment diagram. And I will stop at bending moment. Normal thrust and all, we'll take it tomorrow. Because too much it will be, or else today you will get confused. So this is your arch, right? And here was your point A, and this was your point B. And this is your point C, correct? Then at 12 meters, here you had your point D, and here you have your point E. So these are your various points A, B, C, D.
E. We will require this. Now, A0, I will use a red pen. A moment is 0, B moment is 0, C moment is 0. Good. Moment at E is minus 150. So above this is plus, below this is minus. So randomly somewhere here I will show 150 kilonewton meter below, inside. Okay. So 150 kilonewton, that is moment at E. We have found that. So 150, and moment at D is plus 336. So this is D plus 336 somewhere on top. 336 kilonewton meter. Okay. So these are your 2 points. How you will do is you will join the dots. Okay. Then it is point load, no? From there, get down and shade this area. This is your bending moment diagram. This is your E point. This is your bending moment diagram in case of a arch, 3-hinged arch. It is very important you show this 0 because it is hinge over there. So it is passing to 0. That's why first I marked these zeros. There the line has to pass as it is. E and D, you get 2 values, you just join that line. Any doubts you have till here? Any doubts?
Ma'am, why movement at A, C and
No.
B 0?
This is ABC is hinge, no beta. Hinge beams, hinge support. When you draw a simply supported beam, I give you a ask you to draw bending moment at a simply supported beam. Say I give you a roller and a hinge. So यहाँ पे you have a point load say P. When you draw the bending moment diagram, moment at A and moment at B you write 0, no? And at this point you will get this way. These two are 0. Why they are 0? Because there
There
is
is no
support. There is a
yes, ma'am.
no, because it is a hinge or a roller support. So at that point the moments are 0. Fixed moment when you have cantilever, that only if you have a cantilever beam like this. Do we have 0 at this junction or we have 0 at this junction? Say you have a
0
point.
free end, ma'am.
Your bending moment would be like this, no?
Yes, ma'am.
So free end pay you write it as 0. Whereas the fixed pay you will have the value of moment, maximum value in fact. Similarly, when simply supported beams are there, your supports will have 0 moments always. And because supports have 0 moments, where bending moment is 0, then I compare it with the shear force would be like this. So where moments are 0, you will have shear force values more. And where moment is more, the shear force is 0. There is a statement only. Wherever the bending moment is maximum, the shear force is going to be 0 respective. And where bending moment is 0, respective shear force is going to be more. So because it is a hinge, so moments are 0. When I say hinge, how many reactions are there? You say horizontal and a vertical rotation is permitted. So moment value, that is different rotation basically. But moment value here is going to be 0. So that is why these three are 0. Always remember these three are going to be 0. Don't get confused on that.
Okay, ma'am.
Okay. Anybody else? Any other doubt? Now, directly I substituted and the value and I got. Okay, there is one more method, portion A to C, portion B to C, and we find the bending moment. That I will tell you tomorrow, and directly substitution of normal thrust and radial shear. Same numerical, we will continue again tomorrow to find this moment once again and the normal thrust and radial shear. Is it okay? Because time is up now, and all of you can put in your chat box the your USNs, name and USN, attendance.